Work out the following integral. We've got 8x to the 4 minus 18x cubed plus 32x squared plus 55x plus 42 divided by 4x minus 3 times x squared plus 4. Right, so writing that out. Now, you might be tempted first of all to try to split this in partial fractions. However, what you need to realise here is the highest power here is x to the 4, and the highest power here will be 4x times x to the squared, which is x cubed, which makes this what's known as an improper algebraic fraction. So you will need to divide first. Now the rule for that, if the power here is the same as the power here, or this one is lower than the highest power here, you must divide first. It's called an improper algebraic fraction. Now this might look quite difficult, but if we break it down into steps, we'll be able to come up with the integral. So multiplying out the denominator first, because we wanted to do a division. So we've got 4x minus 3 x squared plus 4. So we're going to have 4x times x squared plus 4 minus 3 times x squared plus 4. That's going to give me 4x cubed plus 16x from there, and then minus x squared, and change the sign, be careful with the sign, minus 12. So writing it out in order, so we get 4x cubed minus 3x squared plus 16x minus 12. So we now need to do this divided by this. So writing out the division. Now make sure you write everything in the right column when you do this. So the first thing we're going to divide is the ax to the 4th by 4x cubed, and that just gives me 2x. Now you write the 2x here in this, because this is where the x's go. And then you multiply out. So 2x times 4x cubed gives you 8x to the 4. 2x times minus 3x squared gives you minus 6x cubed. 2x times 16x will give you 32x squared. And then 2x times minus 12 will give you minus 24. You then do a subtraction. Here you're going to get nothing. Minus 18 minus 6 gives you minus 12x cubed. 32 minus 32 gives you nothing, so we'll just leave that one blank. And then minus 52 minus 24 will give you minus 31x, bring down the 42. Now the next thing you're going to divide is the minus 12x cubed by 4x cubed, which gives you minus 3. And then multiply out, so you're going to get minus 12x cubed plus 9x squared minus 48x, and then plus 36. Again, you do a subtraction, get nothing from here, you get minus 9x squared, you've got nothing minus 9. Minus 32 minus 48 gives you plus 17x, and then 42 minus 36 gives you 6. Now you no longer can divide, so that's the remainder. Right, so writing this out, our division will become 2x minus 3, which is what we've got, plus our remainder, which I've rewritten as 6 plus 17x minus 9x squared, over the divisor, which is 4x minus 3 x squared plus 4. Now this bit here, you can now split into partial fractions. Right, so 6 plus 17x minus 9x squared over 4x minus 3 x squared plus 4. You need to try a over 4x minus 3 plus bx plus c over x squared plus 4. So making a common denominator here, that will become, okay, this is linear with a quadratic factor. Okay, so we got 6 plus 17x minus 9x squared must be to a times x squared plus 4 plus bx plus c times 4x minus 3. Right, so we're going to put x here to 4 over 3. That makes that bracket 0, which means that on this side we will get 219 over 16. Leave it as a fraction, don't use decimals. And then when you put 3 over 4 in here, you get 73 over 16a. So it's 3 over 4 squared plus 4. You'll see the 16s cancel, and the 73 goes into 219 exactly 3 times. So a is 3. The next step when this type, you put x equal to 0. If you put x equal to 0, then the only thing you get left here is the minus 3c when you multiply out. So here on this side you get 6. Here you're going to get 4a minus 3c. A we've already found out to be 3. So we're going to get 6 is equal to 12 minus 3c. 3c is equal to 6. C is equal to 2. To find b, we equate the coefficients of x squared. So here we've got minus 9. Here we've got a. And here we've got 4b. Don't forget it's b times 4. Okay, so it's minus 9 times my value of a plus 4b. That gives me minus 12 is equal to 4b. And then we get b is minus 3. Right, so writing that out, this as a partial fraction will be equal to 3 over 4x minus 3 minus 3x plus 2 over x squared plus 4. If you were to put this here as a minus, that will be 3x and that will have to be minus 2 because the line here does act as a bracket. But at the moment it's probably better just to leave it at that because we're going to now split it up. So splitting this up will become minus 3x over x squared plus 4 plus 2 over x squared plus 4. Right, now putting it all together, our original integral will be the same as integrating 2x minus 3 is what we got when we divided this, plus the remainder in partial fractions. So plus 3 over 4x minus 3 minus 3x over x squared plus 4 plus 2 over x squared plus 4 dx. Right, we're now going to integrate that. Well, this is quite easy when you integrate. It just becomes x squared, and this becomes minus 3x. Now this comes from ln of 4x minus 3. When you differentiate that, you're going to get 4 over 4x minus 3. So we're going to get over 4. We're going to have to divide this by 4, okay, but we've also got the 3 here, so we need the 3. ln of 4x minus 3. Here, ln of x squared plus 4 is 2x over x squared plus 4. So we got the 2. We also have to put in the 3 and then ln of x squared plus 4. Right, this one comes from a standard integral, 1 over a squared plus x squared. We've got 2 over x squared plus 2 squared. This is a standard integral, 1 over a arc tan x over a plus c. So this will become 2 over 2, because there's a 2 here, and a will be 2. 2 over 2 is nothing, so we won't write it out. Arc tan of x over 2 plus c, and this is the final answer to that question. So it started out being quite a complicated integral. We were able to break it down into steps, remembering that when you've got improper algebraic fractions, you must first divide and then put the remainder into partial fractions. Okay, I hope you've understood, and I thank you very much for watching.